can be kind of difficult to parse sometimes in Go. We have here a fake payment API that we're going to be using. So we're going to get a list of payments that we want to execute. Each of those payments has associated with it an ID, an amount, a type, and then a payment details field that we're going to use to somehow execute this payment. The issue here is that the contents of payment details is going to depend on what the type of the payment is. So the first payment's an ACH payment, so its payment details include a routing number and an account number. The second payment is a credit card payment, and that means that its payment details include a card number and an expiration. So the issue here is that if we want to use kind of the standard method of assigning a struct that has a bunch of struct tags that tell it which fields to parse into which fields of the struct, we can't have one type that represents payment details. There are really kind of two different types here, and we don't know which one it's going to be until we parse it. It could be payment details containing ACH information. It could be payment details containing credit card information. So how do we solve this sort of problem in Go? What I've seen most commonly in a variety of projects is to use map of string to empty interface to address this. So if we were going to parse this using those kind of types, we would have a payment collection, which is just a list of payments. We have a payment with an ID, an amount, and a type. And then our payment details field will make a map of string to empty interface. And this will work because we can parse any JSON like object type into a map of string to empty interface. All those objects are really just hashes. Those hashes are always string keyed, and then they map to something. So as long as no one gives us anything really weird for payment details, like an array or something, this will always work for any contents of that field, which means it'll work fine for the routing number, account number version, and it'll work fine for their credit card number, expiration date version. However, when we do this, we end up incurring all of the sort of normal pain of empty interface, right? So when we want to go to execute these payments, we're going to need information from the payment details field to do it. So the first thing we have to do is to look at the type of the payment, figure out if it's an ACH payment. And then if it is an ACH payment, we have to pull out the routing number and the account number out of the payment details field, and then we have to cast them to strings, right? So for starters, we have the basic issue here of now we have a bunch of casts. We have to do error handling for that. We have issues with being able to know what our types really are under the hood, which can make this hard to debug and hard to understand. And this is especially painful because we could have caught bugs like these when we were parsing this if we knew what we were supposed to parse, right? If someone was passing us a routing number that was an integer instead of a string, we should be able to detect that when we call JSON unmarshal, right? If you try to unmarshal a string into a field that's an integer, you'll get back an error that you can deal with, but this way we only find out kind of much later after we've already parsed. The other issue here is that payment details as a field has none of the context needed to understand what it is, right? So if this map of string to empty interface ever gets separated from the type, we have no idea what's going to be in it, which means if we want to pass this around to various different functions, right, we're always going to have to pass the type along with it, because without the type, we lose the ability to understand what's actually going to be in this map. And that gets especially painful as your code base grows, right? I mean, this is a kind of a toy example, but you can imagine that there were many more layers of indirection here, and for each layer of indirection, we would need to make sure that we're always including the type information, because if we ever separate it from that, we no longer have any idea what's in this map. So essentially, this talk is a PSA that if you find yourself using map of string to empty interface a lot for this sort of thing, there is already a great tool in the standard library to help you with that, and that tool is JSON raw message. So the way to use JSON raw message in this case is that we want to be lazy. So we can define our types like a payment collection and a payment struct, just like before. But in this case, we're going to make the detail field a JSON raw message. And for those of you who aren't familiar with the type, JSON raw message is just a type alias for a slice of byte that defines marshal JSON and unmarshal JSON to not do anything. So if you unmarshal some bytes into it, it just holds those bytes. If you marshal it to some bytes, it just returns itself. And this is essentially a way for us to tell the JSON parser that I know there's this field called payment details. I know there's information in it. I don't want to do anything with it right now. Just hold on to it, please, and I'll kind of get to it later. Right, because the core issue that we have with the map of string to empty interface version is that we're trying to parse everything all at once. And we could parse it correctly if we had some other information, right? So instead, we're going to wait till we actually have that information and hold off parsing for now. The next step would be to find some types that actually make sense just by themselves. So we have an ACH detail struct and a card detail struct. Those are both going to fulfill some interface that allows us to execute a payment, right? And these look like very normal types. They're very easy to marshal and unmarshal JSON into, and we get all the benefits of type checking, right? If we try to marshal a routing number that's an integer into an ACH detail field, the JSON parser will reject it and give us an error back that says, hey, you tried to put an integer here, but you told me it was going to be a string. And then when we want to actually go to execute the payment, all we have to do is essentially we want to guess correctly. We're going to look at the type of the payment. Based on the type of the payment, we'll initialize one of the two concrete types that we made. And then we're going to marshal into that, and then we get all the kind of benefits of the error checking the marshalling gives us. Plus, again, we now have types where if you see an ACH detail floating around somewhere in your source far away from your parsing logic, you know what it is and you know what fields to expect in it, as opposed to if you just see a map of string to empty interface floating around, you have no idea what's going to be in there. So our conclusions here, we want to use empty interface. A lot of cases, I think it's one that people tend to go to just because it makes the logic so simple, right? Like, you just put map of string to empty interface, and you never have to worry about JSON on Marshall failing on you. But the cost associated with it is that our types, we lose context about what our types are supposed to be doing, and we lose the ability to do kind of our standard type safety stuff. So JSON raw message is a great alternative. It lets us be lazy and put off parsing until we have the information that we need to parse things correctly. And then by delaying parsing that way and using types that make sense, we get all the benefits of type safety and also all the benefits of maintainability of having types that we can look at and understand in our code base. So thank you so much, and please stop using empty interface.